Have you ever been amazed by AI? Well, I have, and the first memory I have of it is when Facebook not only recognized the people in a picture I just uploaded, but also could tell me who they were. Now, of course, we can use this technique for a lot of fields. In radar, for example, we can use it to detect animals, buses, trees, or any other target. But if we were to use an optical camera, we wouldn't see anything on cloudy days. Fortunately, there exist more advanced techniques, such as pulsar, which can capture images not only if there are clouds, but at night and with almost any kind of unfavorable weather. But a new problem arises when using these kind of techniques. In optical imaging, we have three channels: red, green, and blue. And these targets recognition algorithms, such as the one Facebook uses, works with those inputs. However, the radar acquired data is complex valued. Most people deal with this issue by using either only the amplitude of the complex value or just making some kind of input transformation to make the data real valued. But what if instead of adapting the input to the algorithm, we adapt the algorithm to the input? Indeed, we can try using a complex value neural network. I mean, can we? If we were to implement a neural network in Python, we would normally either use TensorFlow from Google or PyTorch from Facebook. Either that, or you will reinvent the wheel. Now in our work, we did the only reasonable thing, and reinvent the wheel, of course. But there's a reason to that madness. None of both tools fully support implementation of a complex value neural network. And now the fun part. We already have the library to implement our code. Now for the fighting to begin. On one side, we have the experienced and conventional real value neural network, and on the other side, we have the new complex value neural network ready to make her stand. They'll be fighting to see who can better classify different pulsar images. And spoiler alert, we have a winner. We had this fight in different flavors, such as dataset splitting, input representation, or model architectures. And although sometimes with a small margin, it was always complex value neural networks who came victorious. If you want more details about this fighting, I advise you to read one of my papers, and if you're patient enough, and you really like reading, I will soon be publishing a big manuscript about it, namely my PhD manuscript. Thank you very much for your attention. And remember, simple is good, but complex is better.